Hi again. This is the video series on how to name and write formulas for ionic compounds. If you watched the previous video, we looked at naming ionic compounds when you have a metal that's in group 1, 2, or 3. And group 1, 2, and 3 metals, they always form the same ionic charge, 1, 2, or 3. If you look at the periodic table here, okay, there are some metals that have what we call variable charge, meaning that they can form different ionic charges. So here, if you look at chromium, it can have a +2 charge or it can have a +3. Therefore, we have to add a little bit to how we name these compounds. Really, there's two ways we can name. I focus mainly on the systematic name, but you are going to do either a systematic name or a common name, okay, for metals that have variable charge. So what you do is you name, in a systematic name, you name the metal. So here it's iron. Okay, and notice these are mostly transition metals, okay, not in group 1, 2, or 3. And then in parenthesis, after you name the metal, you indicate the ionic charge. Okay, this 2, that's a Roman numeral here, is not how many iron atoms you have. Okay, that 2 is the charge of the iron atom, so the ionic charge. If you use the common name, then you're going to end with OUS for the cation that's smaller in charge, and IC for the cation with higher charge. So to show this better here, so for iron it's called ferrous, so OUS would be the +2 charge because that's the smaller charge, and then for the +3 charge you have ferric. Okay, so here's a nice little list here that shows some of the elements with variable charge, and then it shows their common names. Okay, so chromium goes to chromos or chromic. Okay, but if you have chromium 2, this systematic name, you would just put a 2 in Roman numeral and a 3 here. Okay, so you can look through this: copper, copper 1, copper 2, cuprous or cupric, iron 2, iron 3, ferrous or ferric, then mercury, and then those that you see there. Okay, but we're going to focus mainly on the systematic name. Okay, some students see this right away and some need a little more practice, so at the end of the video I'm going to kind of show you how I indicate to my students and show them how to name and how to figure out the number of atoms that would be in the formula, or figure out the charge. Okay, so if you look at a name here, we automatically know, okay, we've got copper, okay, and then I'm going to look and I see that copper is a transition metal, so I know that I've got copper, and in parenthesis, I'm not sure, do I have copper 2 or do I have copper 1? Does it have a +1 charge or a +2? Okay, and then my ending is going to be the same. So I have chlorine there, Cl2, so I drop the I and E and I end with IDE. Okay, what's in question here, what I was trying to say a few minutes ago, is what's the charge of the copper. So if we look back here, we can have copper 1 or we can have copper 2. Okay, and so that's what we have to represent in this Roman numeral. Okay, it does not mean that we have 1 copper or 2 copper. We're talking about the charge. So what's the charge of the cation? All right, since we have 2 chloride atoms in our formula, which means we have a -2 total charge, okay, with that chloride. That means that copper must have a +2 charge to balance that out. Okay, we mentioned in a previous video that our metals and nonmetals are going to bond in a way to give an overall charge of 0. That means they're going to have a stable octet. So if chloride accounts for 2, we have 2 of them, and it has a -2 charge, then the copper has to have a +2 charge to balance that out, because +2 minus 2 equals 0. Okay, and so we would put a 2 here. And so that is shown. Okay. Okay. For the systematic name, we have copper 2, and we know we have chloride. Okay, it's the higher charge, so it's cupric if we did the common name. Okay, so we get copper 2 chloride, that's what I've already written out, and it's also called cupric chloride. Okay, cuprous would be if we had just a 1 charge, ionic charge. Okay, so I'm going to go through just a little system that I use, and you may see these without having to do this, but I just want to show you a few practice problems. So this one is probably the hardest of the classes that we're going to go through of how to name, just because you have this variable charge and you have to find it, okay, or you have to figure out what that charge is. So what I do when I write these, I look here and I notice that I have Mn, that's not Mg, okay, so this is manganese. Okay, and so I see that that is a metal with variable charge, it's a transition metal. Okay, so right away I know I'm going to have to put in parentheses the charge of that metal. Okay, and then I know if I have fluorine, it ends with IDE, so I have fluoride. All right, so I'll go ahead and kind of get my basics down that I already know, but because we have variable charge, I have to figure out what this is. So I set my equation equal to 0 because I know that the overall charge of this compound must be 0, the overall ionic charge. So I look here, and it's understood that I have 1 manganese atom. Okay, and I'm going to put X because that's what I'm trying to find. You could put whatever you want there, but I have 1 atom, and I do not know its charge, okay, right now. Okay. I have 2 fluorine atoms. Okay, and this is where you have to know your charges from the previous videos. Okay, fluorine is in group 7. That means it wants to gain 1 charge, so it always has a -1 charge. All right, so then I look at this, and I solve for X. Okay, X has to be 2, because 1 times 2 is 2. Minus 2 equals 0. Okay? So I have a Roman numeral 2. So what is in fact here is this. This is what I'm representing there. Okay, let's do the next one. So everything has to be equal to 0. This time I have 2 iron atoms. I'm looking for the charge. Okay, for oxygen, so I have iron, and then that's what I'm looking for. And I'm ending in oxide since I have oxygen. Okay, if we look at the periodic table, oxygen's in group 6, meaning it has a -2 ionic charge always, because it wants to gain 2 electrons to have 8. So if I look here, X has to be 3. 2 times 3 is 6, minus 6 equals 0. So we would have iron 3. Okay, and these are the systematic names here. Okay, next I have 10 fluoride. So far with all of our naming, we've just ended in IDE for the nonmetal or the anion. I have 1 10 atom, and I have 2 chlorides. Chloride is a halogen just like fluorine, so it has a -1 charge. Okay. So all I'm doing here is calculating the ionic charge that goes in the Roman numeral, or in the parenthesis. So the Roman numeral that goes in the parenthesis. So X has to be 2, because 1 times 2 is 2, minus 2 equals 0. So this would be 10,2 chloride. If you wanted the common names, you could just go back and look. So for iron here, we have iron 3. So if we go back and look here, iron 3 would be ferric because it's the higher charge. So ferric oxide. Okay, and then for I think 10, okay, we had 10,2 plus. Okay, and so we would use stannous, because that's kind of different there. And so we'd have stannous, and I believe it was chloride as the answer. But for my class, we focus a lot on the systematic names. Okay, so here they are. The biggest difference, the hardest part, in my opinion, is just being able to see what the charge is on your variable metal. And you can do the little calculations, very simple here, and solve for X if that helps you to see that. All right, thank you. See you next time.